think I'm losing my technology here. So we got the Caleb overview, and these are the folks really on the front lines in many ways of this revolution that we've been talking about. You know, Peter, I think I'd like to talk with you first because I think you are what we know is a farmer. Peter's farm is a dairy farm. You have cows. They give milk. They eat crops. And you are also part of products that are, your farm is part of products that all these folks in this community are eating every day.
Correct.
Where do you see a real opportunity for your organization to be technology forward?
In terms of, in my particular case, we're a family dairy farm. We're located 50 miles from the hub here and so forth. And we produce milk on the farm, but we do it basically in a holistic way with many cyclings and so forth in terms of we grow the crops, feed the cows, produce the milk for you to enjoy. That's how we greet people on the farm. And we're currently in a situation on my farm with going on an intergenerational transfer in terms of, I've been fortunate enough that the younger generation has come back to the farm.
Your daughter?
My daughter, who is 24 years old, who has a degree in dairy practice and production and management. And we as a family, we are committed to passing our farm into the future, and we want to see our farm being working land in the area producing food for the communities in the area.
Is her farm going to look like your farm?
Not at all. Not at all. In terms of, we're in the midst of planning it and so forth, and we're doing basically transformational types of steps. We're going to be producing energy on the farm from our manure. So instead of just having, you know, a milk product and so forth, we're also going to be putting in an anaerobic digester to take advantage of the manure that's produced on the farm and making electricity out of that. And in doing that, we're also imposing a whole bunch of environmental good benefits to the farm in terms of what that technology that's going to be used to produce electricity from manure is what's called anaerobic digestion and so forth. And we're going to be the first farm in Connecticut to put in a farm-based anaerobic digester. And that will be the kind of the new heart of the farm, because that is going to take care of a lot of the environmental sustainability things with regards to having animal agriculture. It will take care of our methane emissions and so forth. In fact, we're looking at that our farm will become a very, you know, positive green situation. And also, in addition to that, to take advantage of that energy that's produced on the farm, we are building a new dairy center and so forth, a new barn for the milking cows that will take advantage of electricity and technology to be able to manage that barn and so forth. Thus, we'll be able to reduce basically a lot of the physical workload, you know, on people and so forth, and that's very important.
To go back to what Emily said at the very beginning, these are panels of people who are farmers and scientists and thinkers. You did come from a biotech background, which certainly is contributing to your understanding of what you can do here. Not only we're talking about changing what a farm might look like in the future, Isha, your farm is also quite different. Can you? You're not only changing the farm, you're changing the milk in your farm. Can you explain it?
I don't have a farm, but I run an organization called New Harvest. We're a nonprofit research institute that funds researchers where they are in their universities to explore how we can produce foods from cells. And so,
cellular agriculture.
Yes.
Explain that to me.
Well, we define cellular agriculture as the production of agriculture products from cell cultures rather than from whole plants or animals. So one of our very, very early projects was the idea that, well, milk is largely made of a handful of casein proteins, whey proteins, really tasty fats, and water. What if we could produce those proteins using a yeast mechanism of fermentation rather than raising mother cows to milk them? And so that is a project that then became its own company called Perfect Day, and they're working towards that goal. And as that was kind of our early stage thing, as we started these two companies, the second one was producing egg proteins in cell culture, we realized that what was really missing for this field was a strong foundation in academic research. And we also switched gears and decided we wanted everything that we do to be as open as possible to prevent some of the issues that arose from the GMO scenario, for example. And so right now we do not have a farm. We have many different labs, and the kind of things that we farm are this big. But we're kind of working towards this goal that perhaps one day there's a farm that can look a lot like a brewery. Probably not exactly the same as a brewery, but you know, these large stainless steel tanks where a biotech process is happening within them. But the people who are doing that work, we don't look at them as mad scientists. We look at them as artisans and craftspeople like we do brewers today. And we think that that could be an interesting future.
We change a lot what we think of in farming, right, in this conversation. So we go from maybe something traditional, something very not traditional. Dorn, you are farming, among other things, you're farming soil.
Right. I think one of the important things that I think we have a common thread here is that we're really beginning to just understand the importance of agriculture and not just farming, and the revolution that Caleb mentioned as far as understanding those complex microbiomes, both in the soil and in the plant, and all the different productive ways we can employ them, either in a lab, in a container, and where we're looking at it is really on the landscape level. And that farming, agriculture is really the culture of the field, and that and farming is really about this collective land management that we're choosing to do. And historically, we've had this process of really land degradation. Civilizations have historically degraded, not improved their land. And what we're beginning to understand now is that rather than taking thousands of years to create an inch of soil, it's really, we didn't understand the processes well enough to realize that what we're actually doing is taking photosynthesis, growing plants, and growing soil through microbial activity at the plant root. So we're building essentially a deep topsoil future, and that's not just producing food. That's an important part of agriculture. We talk a lot about that. But really, it's part of climate regulation. It's part of water management. It's part of ecosystem services. There's this whole host that often the value of which dwarfs just the food production. So this food production is also important, especially in urban areas for distribution. But from a nutrient cycling perspective, growing soil, managing soil is the role of the future agriculturalist. And it's really a collective action that's not just the farmer on their own. They're the ones taking the action, but in order to inform that action, it's really a process of using the technology that we're developing, a lot of it, especially open source technology, so that it is trusted, taking that data, being able to move from where we have been relying on expert recommendations that work in general, to being able to move towards site-specific recommendations to transform each individual farm at whatever scale to build soil and collectively improve the productivity of that natural resource. Because it's essentially a biological accounting book. Yeah. So we can...
So you talk about, in a sense, taking data, which you can use to enrich the soil that is your system.
Right, yeah, so essentially being able to take exactly, being able to do what we call adaptive management. So by understanding the system, we can make small changes to it to effectively improve the productivity, reduce the inputs, and increase the resilience of that system, which in the context of climate change is especially important. So agriculture is really one of the main solutions, not only to adapt to climate change by holding water and restoring degraded landscapes as a method of adapting, but also to mitigate. So we talk about the surplus of atmospheric carbon, but really what we're looking at globally is a deficit of carbon in our soils. And only it doesn't take a large growth rate in our agricultural soil carbon to have a dramatic effect. So just to give a sense, a degraded soil might be, say, 2% organic matter or 1%, which represents a lot of our soils, and a really healthy soil might be 8%. Just a 0.5% increase over 10 years essentially puts us on track to get to where we need to be with the Paris Climate Accord. So,
with the Accords, all right. Geoff, I think that this is sort of the transition to where you are, because once again, what you're doing at Indigo is taking the data of what you can now know and using that to help the plants help themselves, in effect, in a way.
Great description. The foundation of what we do is focused on the plant microbiome. So first, what is a microbiome? Microbiome is a community of microbes that can live in soil, can live on us, in us, lives on this carpet. Turns out we're all surrounded by microbes. And one of the revelations in human healthcare we realized had deep relevance to the future of agriculture. And that's that not only can microbes sometimes harm us as people, if you snap freeze us at any instant in time, even when we're sick, the vast majority of microbes that we are relating to are actually vital to our health. And it's probably almost best thought of in human anatomy that the microbes that live in your gut and live on your skin are like an extra organ that we've just really started to tap into in the last 10 years. The reason they're so vital is simply that their health, the microbes' health, depends on ours. And about 6 years ago, we made the observation that precipitated Indigo, which was that it turns out that if you cut any plant in the world open, they're full of microbes that live inside of their tissues. So
Well, of course they would be. That makes sense, right?
I guess when you think that microbes have been here for billions of years before plants, it would seem that microbes would figure out a way to cohabitate with this extraordinary home that is represented by the inside of plants. But we had posited that the evolutionary implications of that could be vast, i.e. that those microbes would therefore be motivated to affect any stress that could compromise the plant's health. They depend on the plant.
So drought or other conditions?
Every trait that's important to agriculture. So drought stress, heat, salt, cold, viral infections, bacterial, fungal, insects. So what we've tapped into is a means by which to borrow naturally occurring microbes that have spent thousands or millions of years in Mother Nature's lab figuring out ways of being able to quite powerfully affect the plant's resilience to a wide spectrum of stresses. And our job is to figure those out with data, i.e. what is it about the microbiome of an extraordinary crop or plant that allows it to be that way? Or what is it about the microbiome of a rare plant that's capable of living in the desert year-round that potentially is driving the plant to be able to survive those extraordinary stresses. So it involves a lot of data in microbiology, and now our team is just over 200 people, most of whom are scientists, microbiologists, plant scientists, and now a growing commercial arm. And what we've been seeing are in fact true to the depth of this relationship between microbes and plants, that if you discover the right microbes, they can have an extraordinary impact on a plant's survival under drought stress, under heat stress. And as we've moved our first commercial crops into the hands of farmers, we've been seeing consistent 5 to 10% increases in yield associated by simply changing or augmenting the microbiome of seeds at the time of planting and changing nothing else.
Yeah, well, I wanted to just jump in there also just to say that the overlap with sort of an understanding that microbiome on the outside of that plant root is also just emerging, as much as it's sort of been, and really just in the last 5 years, I would say, that the bacterial and fungal populations and the roles they play in soil health and is really a revolution in understanding these processes and how fast we can positively affect our natural environment through understanding. It's really this knowledge-limited system that we're able to, that we're really at this point limited by how quickly can we transmit peer-to-peer our observations to positively affect the system.
There's a really important change that really has just been in about the past 10 years, where previously the techniques to culture microbes were there, and the techniques to painstakingly characterize one of them were there, but you really didn't have the sort of advances in characterization of complex communities of microbes, data scientists to be able to aggregate and understand that, so that as you understand one piece of the puzzle, you start to understand more and more of the aggregate whole of it. And i.e., therefore, when you solve one problem, for example, our first products were improving drought tolerance and water stress management in cotton, it opened up a bunch of perspectives by which we could then do the same for winter wheat, spring wheat, start to do the same for other crops.
Peter, this also reaches your farm.
Absolutely. We're in a situation for a farmer, one of the #1 jobs that we have is to be a steward of the land, and that is specifically to focus on soil health. And we have a particular programs on our farm that are there just to augment and to make soils healthier for the future. I want to be able to pass on the soils in my land that are more productive and so forth to the next generation. And the things that I'm hearing on this panel are some of the things that have been recognized by farmers for years. For a dairy cow, we don't necessarily feed the cow, we're feeding the microbiome that's in the rumen and so forth. That is what, and the microbiome of the rumen is what feeds the cow and so forth. On our farm, we mix up what's called a total mixed ration, not to feed the cow, but to feed the microbiome inside the cow. Likewise, for soil health, we use what's called a diverse cover crop in the fall time. After we harvest our crops, we go out and plant what's called a diverse cover crop, and that is broadleaf and grasses and other things to help minimize or improve the effect of soil compaction. And because we plant different species, we have different relationships with different microbiomes on each of those species. And when that crop is terminated in the next fall, in the next springtime with the next planting, that crop dies, and there's a tremendous release or a benefit to the next crop, which is mostly on my farm, corn and so forth. We've been using diverse cover crops on my farm for the past 5 or 6 years. This is just what these gentlemen are saying. This awareness has been coming out over the past 5 to 10 years, and farmers do recognize the importance of the microbiome. And what I'm hearing is that there's going to be some fine tuning, and so forth with regards to overall.
I keep hearing this from all of you, that the essential nature of open source, just the exchange of information, where it might seem radically different, what the 4 of you are doing, it all comes back. You need that. You need that access to information.
We found, I think, in the back room here, waiting to come on stage, we were having a great deal of conversation because we're meeting one another from different walks of life and so forth, and I as a farmer see the commonality in what the messaging is from these other organizations and people today.
Even with what Isha is
Absolutely.
doing, which is not meant to rival necessarily. I mean, you're not trying to run Peter out of business here, but.
No, I think open source is very crucial because we need to be sharing information with one another if we are to move towards better products and better processes and things like that. And I mean, farming to date has been largely open source, and it's only when we started introducing private things and protected seeds and so on that it kind of changed a little bit. And so I think part of our interest in doing this cellular agriculture work open is because we believe it's so early and could be potentially very transformative that we need everybody to have their eyes on it and everyone to understand what's going on with it and what the implications are so that we can continue to understand what it is as it is developing rather than have it develop behind closed doors and then one day it's out there and we're all consuming it and we never had a chance to understand how it worked or where it came from or why it was even made the way it was.
Does all of your work, we talked earlier about climate change and the developing world, and is that always sort of those kinds of issues always sitting on top of other things that you're doing? Because, we could think in sort of a closed world way about American farming and American industry and everything, but really everything you're doing connects somewhere out there to the future of production of food anywhere.
I would say absolutely. I think it's entirely applicable to our domestic agricultural production too. But I think it's in our collective interest. Even the fundamental nature of agriculture is independence, and it's it's the way in which we're able to create abundance from our natural environment on a regenerative way. And I think that is a shared human endeavor. By sharing what we're doing, we have the ability to not only improve our local environment, but by sharing it globally, we have a collective interest in improving our climate and our natural resources that really are, we're talking about managing global commons at this point. And just to finish, I think that because of that, it's in our interest, as you say, to trust the knowledge that's so important in developing that agriculture, but also to get it in the hands of every farmer every person who has an interest in engaging in this. We should, I think that's part of our collective interest if we're going to move and progress.
A thought that bridges to a point Caleb made, which was that agriculture is a technology, is that partially for the reasons you state, its implications for climate change, its implications for our health, the you are what you eat, which is that agriculture's product isn't just food, it's us. Like at the end of the day, the atoms from the apples that we eat become the atoms in our stem cells and our neurons. It's easy to make a case that it's the world's most important life science technology, and that technology in agriculture isn't just planes, chemistries, tractors, but it's actually the biology of how can we, sustainably and with greater and greater attention to the environment, to consumer health, and to the profitability of farmers, enable this beautiful biological process of plants all around the world gathering atoms from the air around them and the soil around them and converting it into the food that we eat.
I'm going to encourage people to step up with their questions, but I am struck, for those who don't know, your company has done tremendously well. Indigo is now one of the great unicorns of this area. Does this also represent, though, a realization in industry, in communities, among consumers, that, holy cow, we really, really need to invest in all technologies that bring us food?
So I think so, but I also think and hope that it's just the very start. So placing that centrality of agriculture, it doesn't get that degree of attention. I mean, if you look at the local universities around here, people aren't holding agriculture up as sort of the problem to be working on, where entrepreneurs, technologists, biologists, physicists would be thinking first about how do we invent the future of this industry, and in the press it's very easy to come across doomsday pictures for agriculture, and many of those have hard facts around them of detrimental environmental implications of current agricultural practices, etc. If you take the optimist's viewpoint on that, it's incredible. We have a chance in our lifetime to reinvent perhaps the technology which enabled human civilization in the first place, and to improve it and make it more natural and make it better for consumers, make it better for the environment. So instead of taking these as givens that they need to be detrimental or that these are trends that aren't reversible, I think in the first instance, it's better to posit that we could, in fact, globally create a better version of this. And that's part of
something that is meaningful to all of us. There's a gentleman in the back here.
So the speaker on the right, you had mentioned about how...
Who's right?
Dorn.
My right. You mentioned about how if we increase the soil organic carbon by 0.5% across agricultural fields, we'll be able to draw down CO2 in the atmosphere. And I believe that that is the easiest way to draw that CO2 down. I think the technology is close or there, and we know how to do that, but what's the financial model that's going to allow the Midwest to, the corn, soybean farmer to implement that?
Well, that's kind of the lovely piece of it is that it's a win. It's one of those few instances where we have a win-win situation, that there is an intrinsic value of actually increasing organic matter in production systems. And one of the key pieces is the use of cover crops, which are a biological primer. So I'd say it's not even technology as much as it's biology, as we were saying. And so there's an intrinsic value in the production system to lower input costs and maintain yields. And that's what the data is really showing. And so it's really a process of social exchange. At this point, it isn't a question of technology. It's about technology transfer, knowledge transfer. Then we have, on top of that, so it makes sense at the farm level for increasing water capacity, decreasing necessary herbicide use, decreasing fertilizer use, letting the biology do the work of the mined and imported inputs. Then we have the public interest in accelerating this process. And so that's where we have some really interesting ecosystem service markets that I think can be built. We have some interim steps that through, there are all sorts of environmental quality incentive programs that pay for practices. But we're on the edge. This is part of the technological revolution. And be able to develop this, essentially, this nervous system for the natural environment using the low cost of observation technology and remote sensing and so forth in combination.
So the drones and the
all
soil
of this is part of an
assessment.
ecosystem that allows us to move from essentially indicators to actual measurement of results on the ground, and the portion that we are contributing, either improving or degrading. So we have again this global accountability that's just emerging to be able to provide incentives from a public perspective.
It is an investment for a farmer, right?
It is.
I mean,
you do have to make the investment to say, plant the cover crop or whatever. Your question was specifically, what can a farmer do in the Midwest, to do some of these things? Like Dorn said, use of a cover crop, specifically a diverse cover crop, and also minimum till or no till. Okay, those are tremendous technologies that allow for the buildup of carbon in soil and not to plow.
And in general, that's reducing labor, it's reducing fuel costs, it's reducing input costs. All of those things sort of feed into but it just requires a shift in culture.
And the thing is, the thing about a cover crop is not new. George Washington, our founding father, planted cover crops on his farm.
And entrepreneurs should brace for that adoption curve of new technologies. One more point about business models is right now, in many ways, I think the anxiety in the food system is in part because consumers feel divorced from many agricultural practices. And that has to change in that if you imagine going to the grocery and not just having, sort of organic as a category or the assumption of industrial agriculture, but imagine that parsed into a portfolio of 50 different things where you as a consumer could actually vote as to what kinds of practices should be taking place on farms. And if you could really start to measure sustainable practices and codify them in an open sourced and community fashion, and create potentially customized logistics to connect specialized agricultural practices to what consumers have available to purchase, you'd open up a means by which to potentially add a dramatic amount of value into agriculture, where farmers would love to alter practices according to measurable outputs that consumers may strongly prefer over alternatives. Nutrient density being one of with a more rich biological system that's part of the outcome that I think will happen as we begin to be able to study these things in place. We'll be able to measure the health effects of the agricultural practices in the final product.
This is one of the areas that's we've taken very seriously at our farm in terms of our milk going off our farm goes directly into the marketplace. I belong to 2 farmer cooperatives that market directly to consumers, and they're available in the Boston market here. Cabot cheese and the farmer's cow milk products. And with those products introductions in the marketplace, I get feedback with regards to from consumers. One of the biggest things that we hear from consumers as a farmer is that food comes from the back room of a supermarket. that's some of the perceptions out there. On my farm, we put away a public area. We host the public, and we have open houses just to educate the public how their food is produced. And on, in July, we have an open house, third Sunday of the month, which is National Ice Cream Day. We'll have one next year, third Sunday of July. And during that time period, we can have over 1,000 people show up at the farm. We ply them with a little ice cream, but they learn about where their food is coming from. And in addition, we do outreach and other educational programs in terms of just telling people, teaching them where their food comes from, because people don't necessarily know. And this also gets into a more important thing as some of these technologies are going to start coming onto the marketplace. There has to be consumer education. There has to be outreach, with regards to educating the consumers about what these technologies are and what the benefits are to them. Because after all, it really is all about the consumer.
I just want to get a last word from Isha on that subject of education and thinking into the future. On your website, you refer to Winston Churchill's quote about in the future, and 50 years in the future. This is Winston Churchill in the 1930s.
Yes.
50 years from now, you'll be able to have chicken wings without the chicken.
Right.
There is, apparently we were late on this, but he was ahead of the game. Look ahead. Where do we need to be? What do we need to know?
What do we need to know about the future, or how should we educate people about the future? I think I want to go back to what Geoff was saying about agriculture and how it attracts or does not attract people. I find it interesting that I go to so many panels like this, and a lot of the innovators in food science didn't necessarily come from an agriculture background and are trying to get involved and are adapting kind of technologies that they learned from a completely different field into agriculture. I think we need to be creating systems and education that allows for that to happen more easily, because right now it's not very easy for someone to even go to an agriculture school, or for an agriculture school to work with a school that specializes in biomedical engineering, for example, which is something that we find very hard to do as we try and match researchers up together. So I think part of the education is finding those people who do want to build this new agricultural future and enabling them to do so by introducing them to agriculture very early. And I would like to see, the best and brightest be excited to go to a land-grant school as much as they would want to go to a more famous kind of school. And I think maybe it's because I'm from Canada that was possible for me.
Well, it is certainly a time for interdisciplinary thinking in this process.
Absolutely.
Thank you all for speaking with us. Enjoy the conversation.
Thank you.